The industrial Internet of Things is enabling a revolution of data and improved operations, with opportunities for better control, faster data collection, direct transmission from the plant floor to the cloud, and enhanced diagnostics and analytics. Improved data collection starts with making data available. In the past, we used analog sensors that provided one value with low resolution. Later, digital sensors were introduced to allow several values at a higher resolution to be provided to the control system. Now, smart sensors and actuators allow us to gather large numbers of values with high resolution directly from the field device. In this video, I will introduce you to how these advanced tools and IIoT concepts enhance data acquisition and control, offering richer information for predictive maintenance, energy management, and more. Smart sensors and actuators are critical components of many advanced technologies, including the Industrial Internet of Things or IIoT devices, industrial automation, robotics, analyzers, and more. A smart sensor is a device that takes input from the physical environment, like a flow or pressure, and uses its built-in computing resources to perform predefined functions upon direction of specific input, and then process data before passing it on. Smart actuators are similar in their capabilities to smart sensors. Using similar constructions of digital communications and microprocessor-based data collection and analysis, smart actuators integrate additional capabilities such as control algorithms and communication interfaces. Smart sensors and actuators are important in automation because their enhanced processing capabilities allow the sensor to store its own configuration parameters, scale the input to a specified range or signal level, generate alarms, determine the health of the sensor through diagnostic routines, and provide calculated values such as totalized flow or average temperature. For example, the Aventix AF2 flow sensor can measure not only the airflow rate, but also pressure, temperature, and velocity. This allows for complex variables, such as mass flow rate, to be calculated by forwarding the sensor data to a computing device on the network in real time. It is clear to see that smart sensors and actuators are critical to achieving precision control, leveraging diagnostics and monitoring capabilities to aid in preventative and predictive maintenance, and ensuring connectivity and seamless integration between devices and control systems. Manufacturers offer almost all types of sensors as smart sensors, including level sensors, pressure sensors, temperature sensors, proximity sensors, flow sensors, analytical sensors such as pH and conductivity, and many others. Smart sensors typically utilize digital communication protocols such as Ethernet, OPC UA, MQTT, or I/O Link to provide fast, efficient real-time data transfer. A smart sensor also usually includes a microprocessor or microcontroller for data processing. These microprocessors can often run complex algorithms, enabling the sensor to interpret the data it collects, make decisions, or even learn from the patterns it identifies. These digital communication protocols provide easy installation with quick connect cables that carry both power and signal. Provisioning is fast, and in most cases, able to be performed while the system is operating. This allows sensors to be added or replaced without fear of disrupting the network. Modern manufacturing methods enable today's smart sensors to be produced with higher sensitivity and data resolution than ever before. Manufacturers have developed technologies over time that allow for minute changes in the process to be detected. These measurements are converted to digital signals using state-of-the-art circuits and microchips, which give precise measurements, sometimes even up to 32-bit precision. With so many smart sensors to choose from, the automation engineer has a range of communication protocols, data collection rates, and cybersecurity profiles from which to choose. Smart devices are becoming a valuable tool in every automation engineer's toolbox. As processing power becomes more powerful and more compact, smart sensors and actuators will be able to deliver not only more data, but more relevant data, to allow for more precise control, enhanced diagnostics, and connectivity across the plant floor and beyond. Data transmission speeds and bandwidths will increase, allowing for bidirectional data flows, enabling autonomous operations, real-time control decisions, and adaptive control to improve throughput and process efficiencies. Smart sensors and actuators, through Ethernet interfaces, will provide connectivity through IIoT networks that span from the plant floor to the cloud. IIoT is comprised of a network of physical objects or things embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the Internet. Smart IIoT devices, like smart sensors and actuators, can provide real-time visibility into the location, status, and performance of every asset in a facility. For example, smart devices and networks support totally integrated data and control, with the ability to store large amounts of plant floor data in data lakes that can be used for advanced analytics, such as multivariate control, machine learning, and optimization routines. The more you learn about smart sensors and actuators, the better positioned you will be to apply these concepts to real situations in your plant or client's plant or project. These strategies are likely new to your own plant engineers or client's engineers, and being in a position to offer sound technical advice can be extremely valuable to those individuals. I hope you will continue your learning by completing the IIoT Fundamentals Smart Sensors and Actuators and Automation course at realpars.com. This course was created together with Emerson. After finishing, you'll get a completion certificate from Emerson. You can find the link below.